KBYP in the ham shack down the rabbit hole of the HP 8660, recapping and throwing out as much of the original power supply as possible and replacing it with switch mode supplies. But the first job is to recap this monster. No one on the HP Agilent list had a clue how to make a courteous post in any capacity, let alone know anything about this unit. There's nothing on these forums anymore but trolls, which are no-code licensee hams that have a government license and think they know something. So it appears that people that know about this kind of equipment either dead and gone or lost interest. So I'm on my own. First section is this control unit with the microcomputer in it. And I found some significant problems and chances to cause significant damage just by taking that unit out. Let's turn the dit dot down. If you see here in the front, there are 4 of these bevels and screws go through them to hold that unit in. So take those out. And as extremely carefully as you can, very slowly start sliding that unit out. Because inside there is this. See the ribbon cable all folded up? That's a major no-no, but we can't change it. Only way to unfold that is take it out and warm it up, heat it up, and then slowly bend it. But there's that. And down inside there, an RF connector that interferes with that capacitor. It has to be pulled up. There's the other half of it. Be extremely careful taking these jumpers off. Most of these header pins I've seen in the consumer world are fairly hard. These are very soft. They bend real easy. And I pried these up with a screwdriver, one side, the other side, back and forth. But that last little bit of lifting it off, I tilted it slightly and it bent the pins. That's very bad. And by the way, I'm grounded. Don't even think about working on this without being on an anti-static mat. If 40 bucks isn't worth it, give it up. And grounding. There's a funky connector pair up here with 2 screws through it that come out. And you can see the bent pins on the bottom of that header. I got to straighten out. So, bent 2 sets of them in the process. Shame on me. Be very careful taking the boards out of this unit. I thought I would just summarily start with the first one. It has the header on it. This Giddy Gadget here. Thought I'd kind of summarily start with the front, work the way back. Don't do that. Take the second board out first. And take these out by taking this top cover off. Don't take this shield off, but use this for a wedge and lift up a 1/16 or 1/8 of an inch at a time on each side and work the boards out. Don't try to pull them straight out because they probably won't go. And don't use tools. But this ribbon cable interferes with removing this board, so you can't just pull this board out. So take the second one out first. That leaves room to pop the first one loose and move it back and then lift it out. Don't bend these cables in more than necessary, especially at the sockets. So when the first board's recapped, I'll put it back in. Take the next one out. Put the second one back in after it's done. So I'll just leave a space as it goes back. Recapping these boards is a PITA because some dumbass at HP or whoever made this decided they were going to cinch the leads. Common term heard in assembly. Sounds sophisticated and important. I cinched the leads. Yep, you sure did. That leaves a possibility of breaking the leads, breaking the solder joint, pulling a lead loose inside the component. And the gotcha. If you go to reheat these leads to pull lead out, if you heat that solder joint and pry up, and there's a play through hole, it'll rip a play through hole right out of the board. Then you got to find everywhere that PTH goes and run jumper wires. This is why we do not cinch leads. For crime and Italy, we got super glue. Bend the leads, put a dot of super glue on the bottom, put the thing through, the super glue will set instantly. That even works with surface mount. although it stinks. Never cinch component leads, ever. I don't care what somebody at NASA thinks, because the dipwads don't have to fix a thing in the future. I'm real concerned about electrostatic discharge, always should be. These are LS components. They're not, that's TTL, but they're still static sensitive, but they're not HC. The way to properly get these capacitors out is, for example, let's say that's a capacitor lead. See the lead bent over? Firstly, 10, 15 minutes, an hour, or a day before, touch a little diluted rosin flux on each of the solder joints, both sides of each of the capacitors, and let it dry. Give it time to work. It's a chemical reaction, it's got to have time. When you're about to solder the lead, heat the original joint and touch some new solder in to, in my term, freshen the solder. While it's hot, take the soldering iron tip and bend that bent lead straight up. Then when you heat it and pull that lead through, it'll pull straight out. Be absolutely sure you've heated the joint all the way through, because this is a double-sided board. If that solder isn't completely melted on both sides, it can pull the plated through hole right out of the board. On the other one where the lead's bent, just tip the component so it's straight in line with that lead. Heat the solder, then straighten the component up and just pull it straight out. The other way is cut the leads and take those pieces out. That makes excess heating time on the board. Then to install a new capacitor, check its value, bend the leads. I laid them down like this and bend the leads so they'll clear. That's really no higher than the top of the IC case. Bend the leads. If there isn't enough solder, touch a little more solder on the existing holes. Heat the solder and just slide the lead down in. So, piece of cake, and that's how to do it without damaging the board. Avoid touching the edge card pads, avoid touching the traces. You don't know where they go to or what they do, or how static sensitive they are. After changing them, of course, you check the capacitance value before putting them in. Many of them in this unit are 10% for tantalums. We go with an ohm meter set on low scale and measure across the leads, make sure there are no shorts. Not likely here because there's a very wide spacing, but especially with electrolytic radials, check for shorts under the capacitor. Also, in a unit like this with a lot of boards, don't take all the boards out. In static sensitivity and theory and such, a pin on a device is considered static sensitive if it doesn't connect to anything. In theory, when it's put into a circuit, even on a board that's unpowered, it's much safer. And I apply the same thing to these open socket terminals. I don't know where they go or what they do. Any one of those terminals could go to some place on that board and be about the same condition as taking the board out. So that and reducing the chance of mixing a board up, take one out at a time if possible. That's just less to drop, less to go wrong. And as I find more tricks to getting this monster apart, I'll post additional video segments. KBYP did it.